Oh, okay, we're gonna get started. Hope you all had a great weekend, forgetting about the exam that you took. We'll come back and talk about it probably later this week. Has not been fully graded yet. We're still working on the linked list assignments and getting those back to you. So that should happen over the next couple of days. And then we will eventually get your exams back. I can't talk too much about it yet because there are still a few people who haven't taken it. There's definitely an illness going around for the last couple of weeks. So a few people got sick and that's okay, but PowerPoint crashes on me. What else is using Microsoft products? Eventually, there it is. But I clicked it all. Windows. Hey, I'd like to pick up where I left off. All right, so that's where we're headed. We are working on sorts this week, and we will probably finish those just ahead of the end of the week, where we'll start talking about recursion. And hopefully, I can make this as intuitive as possible for you. Any questions before we dive into sorting? Yeah. We're gonna end up, yeah, the application that we're gonna have for sorting is to add that functionality to our linked lists. Yeah. Yeah, so we want to intuitively understand the sorts on their own so that we can go apply them to sort a linked list. Now, what will happen when we take this generic idea and we'll be talking about it from an array list perspective? What happens when you go implement it to a linked list? That will be what you figure out for your homework. Not too different, but we will also be getting some practice with using the strategy design pattern. You do not have to have taken design patterns ahead of this, but I like to think that this is a very useful, real application of that pattern. So I'll be introducing it like you've never seen it before for the scope of what we will be implementing. So basically, the idea will be that for each list, we want to be able to sort that list with the sorting algorithm that we want to. So rather than building it in and calling exactly that sort, the dot sort that we write for a linked list will be using the sort that we have chosen. So at runtime, we can say the way that I would like to sort is via this. Now sort it that way. So we're headed to that. What did we come up with though for ways of sorting? I introduced selection sort during our review class. But did anyone come up with anything different than selection sort? And give you a reminder of what selection sort was. We're looking through the entire list for the smallest element and swap in the first element with that smallest element. And then we do the exact same thing with the rest of the array. So from position 1, we're looking for the smallest number from position 1 to the end of the list. Since we already found the smallest element, and that's in position 0, we're going to continue looking for what is now the second smallest, the smallest that is left over. Swap that into the first position, move on to the second position. You do that for all positions in the array, and you have a sorted list. Any other ideas? Either what else have we seen before, or other intuitive ideas, 1 and then 2?
Well, the basic idea is like using loops to sort through.
Yeah, we definitely need loops. We need to do something for each element. Yeah. Yeah, that'll be a consistent theme across all 3 of these sorts.
Well, I saw this in a video over the weekend, like.
Yeah.
You have your array and you split it into little groups of 2.
Merge sort.
Yeah, you
Yeah.
swap based on the size, and then you just keep doing that until it's the right order.
Yeah.
I can't explain.
We'll be talking about those kinds of sorts once we've talked about recursion, because that is a recursion based concept. But we will absolutely be implementing that when we go talk about advanced sorts in a few weeks.
What did you say?
It's called merge sort. That's actually the default way that Java sorts. All right, so we've talked about this, but we're gonna, I think, skip around just a little bit because this isn't the original order that I have this in. I have insertion sort first. I'm gonna do selection sort first. Okay, so we're gonna talk about it. Here is our pseudocode, and we will see this throughout every sort that we do. I will use this concept of pseudocode to ground us in reality. What is this sort doing? How does it work? But we're gonna go through it with an example, kind of like we did a couple class periods ago. And see an example of this working. So what I need from people is we will sort a list of however many elements this turns out to be. 3, 4, 5, 6 elements at indices 0, 1, 2, 3, 4, and 5. Shout out some numbers.
12.
What else? Did you get that one?
4.
4. 7. 2 more.
20.
I heard 3 and what else?
27.
27. Interesting. We're gonna have the largest element in the last position. We'll see what that does for us. So the variables we care about, let's go ahead and read the, there's value in being able to read pseudocode and understand, okay, here's the idea of what this code is doing. So let's see if we can read that, understand it, and then come back to implement it with this example on the board. So this says repeat size -1 times. So there are 6 elements in this list. So we're going to be repeating something 5 times. For each of the unsorted elements, if the element is less than the current minimum, set the element as the new minimum. Once this process is complete, once this entire loop is complete, you can see that the indentation is back to that same level. So once that for loop is complete, we're going to swap the minimum with the first unsorted position in the list, and then move forward to the next unsorted position. So set the first unsorted element as the minimum. So here's this concept of the first unsorted element. And we need the minimum. The way that I drew this before is that we also needed the location of the minimum. To be able to do this, swap the minimum with the first unsorted position, we need to know where that minimum is located. So we're also going to store off what I'm going to call min-loc, the location of the minimum. You will see this, that pseudocode doesn't necessarily outline everything that you need. It doesn't give us all of the variables. It doesn't necessarily, there's still critical thinking that needs to happen between understanding the process and writing out what it looks like logically. So we're going to set the first unsorted element as the minimum. So let's write into minimum what is currently in the first position of the array. Now we're going to, for each of the unsorted elements, that is for all of these, we're going to ask if that element is less than the current minimum. Since we already wrote the 12 in there, we don't really have to ask is 12 less than 12, that never will be the case. But we can move forward and say, is 17 less than 12? Since it is not, we are not going to set it as the new minimum. Is 4 less than 12? Yes. So we are going to set that as our new minimum. As we do this, we probably care to write in this that the location of this 4 is at index 2. Now we're asking the current minimum. Is the element less than the current minimum? So is 10 less than 4? No. Is 3 less than 4? Yes. We're going to set the new minimum to be 3. This new location is at 4. Is 27 less than 3? No. Now we've reached the end, so this for loop is over. We are now going to swap the minimum with the first unsorted position. So we need to swap what is currently at index 0 with what is currently at index minloc. So we're going to swap what is at 0 and 4. The result of that will put 3 here and 12 here. Then we move on, because it said repeat this size minus one times. So we now need to figure out where is the first unsorted element, and that's now going to be at index 1, because we know that we just went and selected the minimum element from the entire list and swapped it into position 0. So we are creating a list that is sorted and dealing with the rest of our list that is unsorted. So now we're going to write the initial minimum and location as 17 and 1. Is 4 less than 17? Yes. So we're going to update. Minimum is 4, the location for this is now 2. 10 is not less than 4, 12 is not less than 4, 27 is not less than 4. So we are now okay to swap position 1 with position minloc. We're going to swap position 1 with position 2. This makes 4 and 17 appear here. We're going to bump this up to now be position 2, and we can see that the sorted portion of our array now contains 2 elements. The unsorted is the remaining 4. We continue through this process. Is this starting to make intuitive sense? Do we feel like we could apply this and write the code? We're going to take a little bit. Go ahead and get in. I like groups of 2 for these kinds of activities. You are okay to work on your own if you would prefer to work on your own, but pair programming is a very powerful tool. What this means is try to divide yourself into 2 roles. You're going to have the implementer and the critical thinker. The implementer's job is to write the code, and the critical thinker's job is to make sure that the code that is being written is correct. That does not mean that the critical thinker is the only person who's doing the critical thinking. That's just that that is what your job is to make sure that the code that is being written is outlined correctly, is being implemented correctly. Everything is going to be okay once this is done. It's a very important voice of reason to say, but what about, or I don't think this is being done correctly. That causes us to come back and talk again. So you're both responsible for writing the correct code. Bounce those ideas off of each other, but have one person's main responsibility being the typer and one person's main responsibility being the abstract. Is this going to work when we're done?
Do you want us to just do it in the single bus? For a server?
Let's do a separate piece of code for now.
Alright.
So everything is going to be outside of the scope. Don't worry about doing it for anything other than integers, and only assume that you're working with array lists for the moment. You can use built-in Java array lists if you like. You may want to write a separate swap function. Swap is going to be used by all of these sorts, so it's something that you could just implement. If we were writing a swap, what would the parameters be? We need 2 indices. Yeah. We need to know where we're swapping in the list. So probably pass in the list, pass in first index, pass in second index. And then we'll swap the 2 positions at those 2 positions in that list. Go ahead and give this a shot, and we're going to write it together afterwards. You have a lot of people starting to work by yourselves. This is something that I notice. I would think that in general, it will be more useful if more people are working in pairs than are working by themselves. Introduce yourself to a neighbor, someone around you.
I didn't check.
I would just default before we sort.
Yeah,
So, yeah, we shouldn't even index or. And then the inner one. We can just do like 4 in J.
We're not turning anything.
Yeah. And then make a for loop there, so like 4 on each J. And then we can have J equal I plus 1, right? Because we don't need to check the same location, since we don't get down, it's just equal to itself, so it's really like J equals I plus 1. And then,
Is anyone working by themselves and would prefer to find someone to work with?
yeah, and then well, J is size.
No one will admit to it.
And then J plus.
Okay.
Yeah.
You don't admit to it, I can't help.
Yeah, so then all we have to do, right, so it'll. So now say if. We want the array, so array dot. But in an if statement, so like if array dot get at J. Is less than. I'll just assume it's an integer. Array dot get at J is less than. Array dot get at I. That's that. Location. And then outside of that inner for loop. We do the swap outside of the for loop, because we, so. After that. No, that's. So then you want to store the, right, so you want like some temp. So like in the temp.
We're storing it in.
We're at. Oh, we're at 0. Yeah, so we just have to swap variables, right? So we would want to have a temp variable because we're going to put the value of min block into the value, whatever the value of that.
If we swap
What's that?
We don't have to.
I think we have to swap the variable values, not the indexes. Because we have to just take the value out of this one and put it over here. But then when we put it over here, it overwrites this value, so we have to have it stored off. Swap it.
So now, so I was thinking, I think we still have bought from that zero. Yeah, well, that's still, and then you go on to.
Yeah, that will finish the. That'll go through all of it. So we're about 14.
You want to. That's what. I'll say it's like. And then we. That and that's where it was. So you want to do. That one. Oh, we did that.
So far.
Oh. Like a wild, I guess, I thought that's like such a good. Seven index and then we are going through this as well because that's when it stops. So.
I don't think we need that many.
I think we just declare.
That's our purpose.
I think, yeah, and then, the only problem with this is that we're creating numbers, right? So we'll have two instances of minimum, so it just adds another element instead of swapping them. So like what we have to do is we have to store off, so we have to just create like a temp variable, so like in temp. Equals or we don't get it, right? But so like I guess, yeah. So. So we're at the current spot where we're gonna swap, right, and store off that variable in town. And now array at I condition. Well, that will. And then we swap. Oh, that one, okay, I see. Okay, yeah, so, and then you do I. Yeah, and then we can swap the array dot get and j. Yeah, and then we would do array. Dot add swap at j, yeah. And then. Right, because that, so now we are taking this variable, storing it away, and then we're swapping.
So temp is.
Turning it,
Do that, yes, yeah, exactly. So I guess.
we gonna swap.
Yeah, so. And then we have to. Yeah. Well, yeah.
We're doing.
What we're at. Well, that's why I want to use. They're storing. What we're doing, say this is variable swap out, right? So we're at index zero. And then we want to take something here, we're storing this away, we're swapping it in, and then we're putting it here. So it's not the min value, it's just like. So that's why I call it. Say that's what it's. So this middle change is the first is. But yeah, it's because we're storing that off, it's in or putting one value to I, and then we're putting our in that way. Yeah, definitely. Yeah, it's step 14. We just kind of build, we feel like two loops, right? So I'm the, it's kind of like a graph goes. We have to go through the list each time. But like it references down there, it'll loop through that inner loop, so because right each time it checks for that average value. The average will be increments each time to swap against about, all right, we'll do that swap pretty much by scoring off the value
Repetition
in our outer loop. Putting the value in our inner loop, so where we find that minimum.
So I should.
So that variable swaps are to.
That is in our outer loop. So that minimum inside of that bit and in the side. That was it. Yeah, that's where it every.
Yeah.
Yeah.
If you think about it, when you're starting at 0,
Right,
right,
index one.
and you want to find the smallest value that's smaller than it's about 0. So you want to hold against this position, you want to do that, whatever's at 0, and then you want to loop through the whole way. So you need to hold that value in the outer loop, and then compare it against each value.
Oh.
So you don't want to do that.
Maybe.
Yeah, so. So the logic that you're identifying is this very first, where is the smallest? And then you're swapping into place. The next thing you want to do is do exactly that same work, starting at 1. So you're gonna end up with some pseudocode like syntax that says.
Yeah, so this is just for what I did. It's just you're storing off
Index.
Makes
And then
sense.
inside of that, you will say,
For each element.
for each,
I, which is, you know, the first iteration,
Mhm.
the first index, right?
Yeah.
And then that index, so we have duplicates.
I'm gonna call this index 2. At or after index.
First index, very swapped.
Do something.
Okay, swapped.
That's where the next.
This is where all of the logic
Yeah, that
that
works.
is less
The
than.
reason I had a temper.
You're gonna do some work right here as well, set up all of the work that's gonna be done here.
So you can do this, this makes sense. Yeah, oh no, this. I don't have.
So that's why I put it there.
No, this makes sense with the name of the fin variable, yeah, that makes sense. And then actually, it can be size minus 1, right? No, because we don't need to compare the last one. So. Or the average. Because we need to go through all the ones in our, so once we get to the last one, and it's really like, we already covered outside that way. So in this one, we're pretty much. We're storing. The value of the minimum index that we found is that, so we're getting the index of the smallest value. Storing the value at that index. And then we are swapping that position in the outer. We don't want to do that, so putting the minimum.
But. We're trying to swap it, like adding it.
Yeah, the add in the array list, if you use this add, it should be.
You're right.
Add, you use add. And then it tends to get, what you do, 2 parameters.
Yes, so you're. I just wonder. If. That will add an extra node instead of the flex. But you should know. But it will, I think by inserting like the insert, like the add, it will still, it will add like. An extra node, but it was, is it like a red place? Like this one works.
Should see our currently.
There should be like a replace or maybe remember. I think. Yeah, so we just use the.
You know, set, you place the only.
There.
Right.
Now, so you can just, yeah. so that will work.
So you're not removing.
Okay.
And then the index and are just reverse.
No.
I think the only. Only one regular is these are all, everything's right.
No, then it's the sort of very, down.
Well,
Index.
Right, so put this, yeah, min lock and yeah, those are the indexes. So we did, so it'd be a rate up, yeah. Yes, the location is the minimum. The index. And then this would be. Because otherwise.
The length between mine and the number.
Oh, yeah.
Basically says. First floor. Second floor.
So you could do like.
Check the. Because part of them, check on the location, right, on page. Visually set ring off. And then that goes like in a outside of that one. So running that. Then it's set, you know.
I'm not.
I know.
And now this is sort of.
Yeah. You try to do it. Well, what is the fuck is that? It's got slow. One.
So.
Do you have any questions?
Use digital based on.
So
I
I
sorted all this.
creative statement.
The first
is
time.
really already.
Wait. Or will it?
But I guess.
Just say that.
Yes, exactly.
So that makes sense.
Yeah, because we're comparing that first position against the rest of the list and seeing if there's anything stable and what's at that first. And we go to the next one, is there anything smaller? And we swap that for each time we move our initial position. I think you can just compare the way to you got time to officer since like it's like we all made American stuff. It's up. Yeah.
Say no.
No, Jason.
Because it will just update. I mean, you could, yeah, it's kind of.
Yeah. It's just like.
Does it? Okay, like, so it's saying what the way. Right, including you call this method.
Yep.
Also.
No, it will just update because you're accessing these fields directly, right, with using the get.
It works in the same array, same location.
Yes, exactly. So it's operating directly on this array. So even if you don't return the array, and then say you print it out before, we print it out after. So we, and I think they kind of iterate, we have to somehow bump up on. So it's, yeah, they had.
All right, let's start doing this together. I see and hear phenomenal work going on. This is great. But we're under just a little bit of a time crunch, so we should probably get going on this. So The first question I have, do we want to use a primitive int array? Do we want to use an array list? Preferences, doesn't really matter which one we implement here. This will just become your starter code. Array list. Let's use an array list. Import us an array list. Okay, so with this, what is the first thing we want to do? Do we want to hop into a loop? Is there anything we need to do to set things up before we hop into a loop? Yeah,
Yeah, another parameter that has like size or something, so like in size.
okay, we could actually get that directly from an array list. An array list stores the size inside of it, so we will have access to that. It's a great point, though. That is something that we will want to consider. Yeah. So we will need some kind of what the current minimum is, as well as the location of that minimum. We'll start there and see if we need to modify this as we move forward. So going into the loop, we know that we need to do this some number of times that approaches but doesn't necessarily, once we've swapped and are looking at the last element, that has to be the minimum that's left in the array, which when there's one element is the maximum. So we don't need to do this that last time, we just need to do it the size -1 times. So I'm going to call this integer that we're going to use as our counting variable, I'm going to call it current. Because that's going to be the current number in the array, the index that we are on. So we're going to start it at 0. And we're going to continue as long as we have not gotten to the size -1. And the reason is once we're at that size -1, then we don't need to consider that anymore. That's the last element that's present in the list as an index. So we're going to say current is less than, not less than or equal to, list dot size -1. Okay, so this is an outer loop that is telling us what index are we currently focusing on. At the very beginning, index 0, we're identifying the smallest number in the entire array. When this loops back, we'll be asking what is the smallest number in the remainder of the array from index 1 on. When it loops around again, what is the smallest remaining number from index 2 on? With the idea that if we've done this, everything else here correctly, by the time we're done with this the first time, the minimum element will have been located and we've swapped it into position 0. So the second pass through, we're looking for the second smallest number, then the third smallest number, then the fourth smallest number. That logic has not been implemented yet, but that is the overall idea of what we want to do. Great. Inside of this, do we know anything about, can we set the values of min or minloc? Since we didn't want to set them outside of this because they didn't have meaning outside of this for loop. It's going to be a different meaning every pass through this outer loop. We have a new minimum and a new minimum location as we go try to answer this question for the ith time. Yeah.
The minimum location would just be current, right?
Yeah, so we're going to say when we do this, minloc for the moment is going to start out as current. What is the minimum? Yeah, the actual value at that position. So we can set min to be list dot get the element at current. Since that is the element that we are starting with. So this is the equivalent of filling that min and minloc box on the board. So that fills it for the first time, guarantees we have a value. We could also do this inside of a loop to start, but yeah,
What is the get do in there? Could you just do list and then current in brackets? That makes sense.
if this were an int array, you could do that. The question is, since it's an array list, yeah, we don't have the ability to do like list of current. If we try to do that, the question is, has it been overloaded to do this? And in Java, we can't actually overload what symbols do. In C++ you can. And in many other languages, you can actually state, I'm going to redefine what these brackets mean to be a call to this method. This .get method. Because an array list is just a class. Underneath this, we actually have an array of that type of object. So that is the field of this object is an int array. When we call .get, the logic of .get is just going and using square brackets on the field of the array list, which is an array. Which is the only way we could possibly make that work. But because we are using an array list, we have to use .get. Great question. So we've set this up, they have values. Now we need to compare these values to everything else in the list. So we are going to say, we now need to, we can start to use a little bit of a dummy variable here. We're gonna start I out at some higher value than current. We want to start looking at the next element in the array. So since current is starting at 0, we want this I to start at the next index in the array, which is going to be index 1. We don't know that for sure, since current is going to be changing. We want this to be current plus 1. Does it make sense why that is? That is the next element in the array in general after the one that is starting what we're doing. Questions on that? Confusions on that? That make sense? Okay. As we do this, we want to continue. Well, again, we're less than the size minus 1. Is that true?
No,
Why?
because you need to go through the entire rest of the.
Yeah, the smallest element could be in that last position. We said less than the size minus 1 on the outer loop, because at the very end, that last element is guaranteed to be the only one. We're not going to swap it with something once we get to that point. But in this case, we want to look at every element up to and including the last element in the list. Yeah.
It looks like those rectangles with all the elements in it, like, it seems like you have a for loop to iterate through one of those like array lists, and then you're having another for loop to iterate through another.
Yes.
Two of them. And the reason why you don't want to set it to -1 is because you want it to go through another.
Right. Once we know the elements before current are all sorted. So there's no reason to look back through stuff that's sorted. So now we want to say less than list.size rather than list.size minus 1. So this is now going to look through everything ahead of current in the list. What do we want to do inside of this for loop?
If list get I is less than n.
Yeah, so we need to do a comparison between the smallest that we've found so far and the wherever I is pointing. So how are we going to do that? We want to say if list.get of I, this element that we are looking for or looking at inside of the inner loop, is less than list.get of, where do we want to look for this? What are we comparing it to? So current would be what's already there.
Oh, we just comparing it to min.
If we compared it to min,
We would want the location.
yeah, we want the location of where this is. Min is the value. min loc is the location. So if we're doing a list.get, we want to make sure we're grabbing the location of where the smallest is rather than the location of the smallest. Using the smallest as an index could give you an array index out of bounds exception.
I'm saying like, you not, like, could you just maybe not even need the dot get, can you just say less than min?
Less than min
Because
loc,
list dot get min log is never gonna give you the value of min.
that would give you the value of min. Okay, so you're saying rather than all of this, just say less than the value of min because we've stored it off. Sure. As long as we're updating that correctly, we can do that. What are we doing inside of this if statement? What do we know if this is the case? What do we want to do?
You can update min and min log.
Yeah, we gotta update min and min loc. So let's set min loc, since now we know there's a new value of min loc. We'll set that to be current. I, what should it be? I. I is that new value that we have found. Yes, so this tells us that the element we're currently looking at inside of this inner loop is the new smallest that we have found. And we will update min to now be that value that exists at index I. Great. So I think this if is done. What else do we want to do after we have identified this? Is there anything else we want to do inside of this inner for loop? Are we ready to loop around this inner for loop and check the next element? Or is there something else we need to do? Yeah,
I mean, we want to swap, but it should be outside of. the
Yes.
inner for loop.
knowing where to swap here is very important. We don't want to swap every time we identify a new potential minimum, the smallest we've seen so far as we're iterating toward the end of the array. Once we've gone through the entire remainder of the array, only then do we want to swap. So we are actually done with our inner for loop, but outside of this, we actually want to swap. How are we going to accomplish a swap? We'll just write it in line here and then we'll consider factoring it out into its own method. How do we swap things? Yeah,
You're gonna have a temporary value and then you can swap. Like say you set the temp to the list.get min loc. And so you would set let's get min loc to or you set it to list.get current.
how do we set in an array list? Yeah, we set at an index. What is the index we want to set at? So we want to set the value of current because we've just stored off the list of the minimum. Yeah,
We don't need to store it off in temp, right, since we already have the min variable.
we do have the min variable. You're correct that we don't necessarily need to do that get, it is stored within min. I would argue that storing this min is probably an inefficiency and will lead to some bugs. If we always wanted to just say the minimum is whatever is at the location min loc. So we should probably factor that out for clarity. So this would just be your minimum. We probably don't need to store it. Let's actually go through that process and say, all right, it's getting annoying at this point to deal with this min. Wherever we're using min, I'm just going to say list.get something. So that's right here. We don't have a minimum anymore. Let's get rid of it. This minimum here is always the location of. What's that min loc? And same here. We don't need to set min anymore, we're always having access to it. So now instead of setting based on min, we can now set at min log. What is it that we want to set at min log? What's the value? Yeah,
Let's not get at current.
yeah. List dot get current. That is right. What comes next? We're not done, we've duplicated a value, but there's something really important that's stored in this temp. We need to put that somewhere.
Just put it up.
Yeah, so we want to list dot set, now instead of min log, we want to set what's at current to be what is currently in temp. Does this swap logic make sense? Is that? All right, this is the entirety of selection sort. This is all it is. We'll validate this and talk about its complexity first thing tomorrow, and then we will dive into the next sort. So I will see you tomorrow for that. I have office hours starting now. If anyone has any questions on the homework or place in the class, how things are going. Yes.
So, also.